I might have been muted this whole time. If this is the first time you're hearing me, I'm sorry. So all I said so far was put my name on it, put a smiley face for the hour because this is for all hours. But when you do your exam, you're going to put your actual hour on there. Hopefully you already know that. All right, question 1. Find the measure of an interior angle of a regular octagon. So key piece of information here is the word octagon. That means 8 sides. And it says an angle. That means that we're looking for just one. And then interior. If you remember one of the things that I said when we did the reference sheet today, I'll draw this out in the margin here. You'll notice that a 1 looks kind of like an I, and a 3 looks kind of like an E. My formula for an interior angle is always going to have a 180. My formula for an exterior angle is always going to have a 360. So here, my formula ends up being theta equals n minus 2 times 180 degrees all over n. And we know what n equals. N is 8 because it's an octagon. So I can rewrite theta equals, in parentheses, 8 minus 2 times 180 degrees all over 8. 8 minus 2 is 6. Really, at this point, I could just go straight to the calculator. So that is what I'm going to do. So I'm going to put in 8 minus 2 times 180 all over 8. And I get 135. Whoops. There we go. So theta equals 135 degrees, and that's my final answer on number 1. Number 2, the measure of an interior angle of a regular polygon is 144 degrees. Classify the polygon by the number of sides. So again, this says an interior angle. So an angle means just one. And then the interior tells us that we're going to use the formula with a 1 in it. So we know that theta equals n minus 2 times 180 degrees, all divided by n. The difference between this and the last one, the difference here is earlier on question 1, we knew what n was and we were looking for theta. Now we know what theta is, but we have to find n. So when we fill all of this in, we're going to write 144 equals n minus 2 times 180 degrees, all divided by n. And at this point I'm kind of stuck. There's really not much I can do to get n by itself except multiply both sides by n. So I think I'm going to use gray to show that. So multiply n times 144, multiply this thing by n. So on the right, the n cancels. On the left, n times 144 equals n minus 2 times 180. I think the next thing that I want to try is distributing that 180 to the n and to the minus 2. So n times 144 equals 180n minus 360. So again, the 180n, that's just 180 times n. The minus 360 is 180 times minus 2. So I might draw in those distribution arrows. So now I'm going to subtract 180n from both sides. And I'm going to do that with the calculator. 144 minus 180 is negative 36. So I should have negative 36n equals 306. Oops. Don't forget that minus there. Equals negative 360. And if I divide both sides by negative 36, n equals 10. Now at this point I have to caution you a little bit. It doesn't say find the number of sides, it says classify by the number of sides. So it's not looking for 10, it's looking for the name of a shape with 10 sides. And that is a decagon. That list should be on your reference sheet. All right, number 3, find the sum of the interior angles of a nonagon. So now we're looking for the sum. So that means all. And that I tells us that, again, we're using just the one with 180. And a nonagon has 9 sides. So our formula here is very similar to the formula that we've been using, just without dividing by n. So theta equals n minus 2 times 180. So we know what n is, that's the number of sides, that's 9. So we can say that theta equals 9 minus 2 times 180. And I can do that directly in my calculator. So 9 minus 2 is 7. 7 times 180 is 1,260. So So I'm going to write theta equals 1,260. Ooh. Okay. Moving on to number 4. The sum of the interior angles of a polygon is 1,800 degrees. Classify the polygon by the number of sides. So this is the same formula we just used. Theta equals n minus 2 times 180 degrees. Only this time, instead of looking for theta, we're trying to find n. So we know that theta, in this case, is 1,800 degrees. And what I noticed pretty quickly, it looks like 180 is going to go into 1,800 pretty nicely. 1,800 is just 180 with another 0. So I know that if I divide both sides by 180, I'm going to end up with 10 equals n minus 2. And that's pretty easy to solve. You just add 2 to both sides. N equals 12. Remember, it says classify, not just write the number. So the classification for a 12-sided polygon is a dodecagon. Beautiful. Number 5, find the sum of the exterior angles. Don't even read the rest. Does not matter. The second you see sum and exterior angles, it's 360. And I guarantee you, you will get a question about that. And I can almost guarantee you that it's going to be a very obscure, very bizarre number of sides. Might be 918 or 74,133 or 66. Some number that has something to do with Tulsa. And you're going to see that, and you're going to say, oh, it's the sum of the exterior angles. It doesn't matter how many sides. I don't have to do math with that big number. It's 360. All right, number 6. The measure of an exterior angle of a regular polygon is approximately 51.43 degrees. Classify the polygon by the number of sides. So again, one of our keywords is exterior. That means that we're going to use a formula that has a 3 in it, the 360. And it says an angle, so that's our keyword that it's just 1. So our formula here, theta equals 360 degrees divided by n. Well, we know what theta is, approximately. We're going to say that 51.43 degrees is approximately 360 degrees divided by n. And to solve that for n, we have to multiply both sides by n. So 51.43 n is approximately 360 degrees. To solve that for n, I got to divide both sides by 51.43. So n is approximately 360 over 51.43. And it's calculator time. The answer I get is 6.99980 something, blah, blah, blah. That is pretty darn close to 7. So we can reasonably guess that n equals 7 because a polygon cannot have 0.9998 sides. The number of sides is always a whole number. So don't ever write 6.99 as your answer here. It's 7 sides. And what do we call something with 7 sides? We call it a heptagon. I'll finish the work on that. Number 7, find the measure of an exterior angle of a regular hexagon. So again, a hexagon is 6 sides. Exterior tells us that we're using the 360 formula. And it's n angle, so we're going to end up dividing by n on here. So same formula as last time. Theta equals 360 degrees divided by n. N is 6, so theta equals 360 degrees divided by 6. And so theta equals 60 degrees. And that's it for the first page. All right, now we got to find the value of x on the next 16 problems. On number 8, what I would do is just count how many angles we've got. We've got 7. And let's see what the 7 angles should add up to. We're going to use our interior angle sum formula. So theta equals n minus 2. Sorry, I'm starting to write it like I'm doing a fraction. Bring that down. Times 180 degrees. So n equals 7. So theta equals 7 minus 2 times 180. Make that look more like a minus there. Ooh, that's worse. That's still not great, but whatever. Calculator time. 7 minus 2 all times 180 is 900 degrees. So that's what all of this should add up to. So we know that 102, I'm starting in this corner and going around. 102 plus 124 plus 146 plus 158 plus 16x plus 34x plus 24x, I'm spilling over into the next problem here, equals 900 degrees. I'm going to combine some like terms. So I can do 102 plus 124, 146. I'm doing this in the calculator. So these add up to 530. And then the coefficients on the x's, 16 plus 34 is 74. I'm going to double check that. I'm second guessing myself. Yep, 74. So 530 plus 74x equals 900. 900 minus 530 is 370. And 370 divided by 74 is 5. Number 9. One of the key things that you need to notice on number 9 is if this interior angle is 90, then this exterior angle is also 90. So we actually do have all 4 exterior angles labeled in some way. We've got a 90, 96, 98, and X. And if you remember from earlier, the exterior angles always add up to 360 degrees. One second. So 90 plus 96 plus 98 plus X equals 360. 90 plus 96 plus 98 is 284. So it's 284 plus X equals 360. And if I subtract 284 from both sides, X is 76. Okay, good. I got my first Rickroll. Thank you. Very good. I've been told that I look a little bit like Rick Astley. I'll take it, I guess. Number 10. This is a quadrilateral. I expect you to kind of just know off the top of your head that the angles in a quadrilateral add up to 360. So we're going to do 90. So I'm starting here and working my way around that way. 90 plus 10x plus 5. Then give myself room over here. Let's move that down here. That's the thing I can do with software. Plus 4x plus 6x plus 5 equals 360. So my like terms here are 90, 5, and 5, it looks like. So that adds up to 100. And then for the x's, it's 10x, 4x, and 6x, so that's 20x. So if I subtract 100 from both sides, I get 20x equals, my mind just blanked, 260. Divide both sides by 20, and x equals 13. Number 11, we've got a parallelogram, and one of the things that we talked about on our reference sheet today is that consecutive angles in a parallelogram are supplementary, so they add to 180. So here I just know that 78 degrees plus x equals 180. I'll subtract 78 from both sides, and x equals 102. Don't really need the degree sign there. Won't count off for including the degree sign, but number 12. So here we've got a rectangle. We know it's a rectangle because opposite sides are congruent, and it has a right angle there. So the opposite sides being congruent tells us that it's some type of parallelogram, and a parallelogram with a right angle there is a rectangle. From that, we can extrapolate. That was a really nerdy way to say that. Holy crap. Because this is a 90-degree angle, we know that this is also a 90-degree angle because it's a rectangle. So if this little piece of a 90 is x, and this little piece of a 90 is 66, then this piece has to just be 90 minus 66. So I'm going to subtract 66 from both sides. I don't know, what is that, 24? Probably shouldn't try to keep doing this in my head. All right, number 13. What I notice right away is it's some kind of parallelogram. That's what the arrows mean. So it means that these two sides are parallel and these two sides are parallel. That's the definition of a parallelogram. And if you have your reference sheet handy, I would look up what kind, so look at the Venn diagram, look at what kind of parallelogram has perpendicular diagonals. It turns out that's only a rhombus. So it has to be a rhombus to have those perpendicular diagonals. And the other thing we know about a rhombus is that all four sides are congruent. So that means that x plus 27 equals 5x minus 9. So I'm going to subtract x from both sides. 27 equals 4x minus 9. Add 9 to both sides. 36 equals 4x. Divide both sides by 4, and x equals 9. So again, it looks kind of intimidating having, like 4 pages worth of problems, but most of these, once you figure out how to set it up, it's just a very quick algebra problem. 14. This is one of the 2 dreaded kite problems. It's really not so bad. The main thing that you need to know about kites for this exam is that there is exactly one pair of opposite one pair of opposite angles that is congruent. You cannot call me Mr. Tickleson. That's silly. Y'all are clowns. I love you, though. I love all my clowns. Hope that made you laugh. Maybe I should just hide the live chat while I'm doing this. I don't know, man. Anyway, clearly this is not the pair of opposite angles that's congruent, because 113 and 55 are 2 different numbers. Hopefully you figured that out before you got to 10th grade geometry. If not, I guess it's never too late to learn. But if these aren't congruent, then this must be the pair that is congruent. So we can go ahead and say that this is also x. And what do you know? Now we have 4 angles that add up to 360. So we say 113 plus x plus 55 plus another x equals 360 degrees. So 113 plus 55 is 168. I should probably be able to do 360 minus 168 in my head. Pull out the calculator, it's 192. So 2x equals 192. So x equals 96. Number 15. It might be hard to tell what those arrows are pointing at. So here's a little strategy for you. If there's no degree sign, it is not talking about angles. I have been very careful while writing these exams. Every label that goes with an angle is going to have a degree sign on it somewhere. Any label that does not go with an angle will not have a degree sign. So that tells us that the 2x plus 8 probably goes with a segment of some kind, and it appears to go with just this one. What I notice is I've got 4 congruent sides. That's a rhombus. And then if I look at my Venn diagram on my reference sheet, it's a rhombus with a right angle. So it's both a rhombus and a rectangle. It's a square. And one thing that we know about the diagonals in a square, since it's a rectangle, the diagonals are congruent to each other, and they bisect each other. So like this piece is equal to that piece, which is equal to that piece, which is equal to that. So basically, these two things we can just set equal to each other. 2x plus 8 equals 4x minus 34. I think I'll add 34 to both sides. So 2x plus 42 equals 4x. Subtract 2x from both sides. 4x minus 2x is 2x. X equals 21. All right. On to page 3. So now we're going to need our mid-segment of a trapezoid formula. And I was pretty picky about this in class today. It doesn't matter which base is which, but do not confuse the base and the mid-segment. So I just drew over those in blue and purple. Our mid-segment formula. The mid-segment is 1/2 of base 1 plus base 2. So when I fill that in, the mid-segment is x. That's what I'm looking for. (20 plus 44 all over 2). 20 plus 44 is 64. And 64 over 2 is 32. Man, this live chat's getting weird. All right, number 17. 17, you can tell, is a parallelogram. You can tell that from the arrows. It says that these two sides are parallel and these two sides are parallel. One of the properties that we know about parallelograms is that opposite angles are congruent. So we can say that 3x minus 15 equals 2x plus 26. I'll subtract 2x from both sides. So x minus 15 equals 26. Add 15 to both sides. What was that, 41? All right, number 18 I want to spend a little bit more time on. It's a little bit trickier. So what I expect you to notice right away is these two arrows tell us that we have one set of parallel sides, and these two tick marks tell us that we have one pair of congruent sides. So this is an isosceles trapezoid. One thing we know about isosceles trapezoids is that the base angles are congruent. And one thing we know about all trapezoids is that angles on the same leg are supplementary. Well, if these two angles are congruent, and this one is supplementary to this one, then this one is also supplementary to that one. So that's all to say 2x minus 16 plus x plus 22 equals 180. So I'm going to combine my like terms. 2x plus x is 3x. Minus 16 and plus 22, that's plus 6. I think I did that right. Second guessing myself. So 3x plus 6 equals 180. 3x equals 174. X equals 58. Number 19. 19 is also a little tricky, but those four congruent sides tell us that this is a rhombus. One thing we know about a rhombus is that opposite angles are congruent. So this is congruent to that. And I knew there was something I forgot to put in the reference sheet. So maybe add this to your reference sheet if you've got it handy while you're watching this. It's a terrible R. There we go. Diagonals of a rhombus bisect opposite angles. So this angle is being bisected by the diagonal. This angle is being bisected by a diagonal. If this angle is being bisected and this half of it is 55, then the other half of it is also 55, otherwise it wouldn't be halves. So the two of them together would be 55 plus 55, which is 110. And this 110 here has to be congruent to that angle there, So x is 55 times 2, or 110. All right, number 20. This is another kite, and sometimes it's hard to remember, which angles are supposed to be congruent. I like to think of a kite as two congruent triangles smashed together. So you can see that this would be side, side, side congruence. A side here, sides there, and sides there. That would imply that these two angles are congruent. So we can go ahead and add in a 102 right there. And just like that, we only have one unknown angle. So x plus 102 plus 47 plus another 102 equals, it's a quadrilateral, so they all add up to 360. So I'm just going to get out my calculator real quick, and I'm going to do 360 minus 102 minus 47 minus 102, and I get 109. Number 21. So again, I think we've already had a diagram kind of like this before. We've got four congruent sides, so it's definitely at least a rhombus, but it's a rhombus with a right angle, and that's called a square. And one thing we know about squares, and really any rhombus, is that the diagonals are perpendicular. So this 2x plus 18, notice it's got a degree sign on it. That means it's talking about an angle. It's talking about a right angle. So all we have to do is 2x plus 18 equals 90. Subtract 18 from both sides, 2x is 72. Divide both sides by 72, and x equals 36. (22). Again, don't forget which parts are your bases and what's your mid segment. Copy down my formula again. The mid segment is base 1 plus base 2 all over 2. Doesn't matter which base is which. That's why I made them both blue. They can be interchangeable. But what you cannot forget is that the mid segment always goes where the M is. So this is going to be 60 equals, one of my bases is x, the other one is 33. So those are added together and divided by 2. To get the x by itself, I need to multiply both sides by 2. So 2 times 60 is 120. So 120 equals x plus 33. Subtract 33 from both sides, and x equals 87. 23. So we can tell from the arrows that we're dealing with a parallelogram. We've got two sets of parallel sides. And it's a parallelogram with a right angle, which is called a rectangle. One thing that we know about a rectangle is that all of the angles are 90 degrees. Another thing that we know about rectangles is that the diagonals bisect each other. So if this length is x, then this length is 2x. Now check this out. Highlight a side in red, blue, and purple. I've got a right triangle here. One of my sides is 24. One of my sides is 10. And one of my sides is 2x. So remember, this is 2x. X is just this piece. We also know that c squared, where c is the hypotenuse, equals a squared plus b squared. Wrong tool. There we go. So 2x all squared equals 24 squared plus 10 squared. Two x all squared is 4x squared. 24 squared is 576. 10 squared is 100. So 4x squared equals 676. 676 divided by 4 is 169. And the square root of 169 is 13. So on 23, x is 13. And we're on the back page already. Give the most specific name for quadrilateral ABCD with the given vertices. So let's start plugging these in. A is at negative 5, 1. So I'm going to go 5 to the left, 1 up. B is at negative 2, 5. So that's 2 to the left, 5 up. C is at 1, 1. So that's 1 right, 1 up. And D is at negative 2, negative 3. So that's 2 to the left, 3 down. So that's A, B, C, D. And just kind of eyeballing it, it looks like it might be a kite or a parallelogram, maybe a rhombus. Let's check all of our properties. So what we need to do is find the length and the slope of each side. So I'm going to start with AB. For AB, my rise is 1, 2, 3, 4, and my run is 1, 2, 3. So the slope is just 4 over 3, that's rise over run. And the length is going to be the square root of 4 squared plus 3 squared. I could just do that in my calculator from there, honestly. You end up getting a length of 5. Now let's look at BC. So here, my rise is actually going down. 1, 2, 3, 4. So my rise is negative 4. And then my run, 1, 2, 3. So my slope is negative 4 over 3. But then when you do the length, turns out that negative 4 squared is the same thing as positive 4 squared. So mathematically, you're still doing that. You end up getting 5 again. So look at that. We've got at least one pair of congruent sides. Let's check CD. So from C to D, my rise is another negative 1, 2, 3, 4. And my run is a negative 1, 2, 3. So my slope is negative 4 over negative 3. Negative over a negative is a positive, so it's just 4 over 3. Hey, that's what we had up there. So we've also got a set of parallel sides. And again, if we do square root of my rise squared plus my run squared, your calculator would tell you that you get 5. So hey, another congruent side. What I want you to notice before I go further, these two slopes are opposites, but they are not reciprocals. So we do not get a 90-degree angle here. So this is not going to be any kind of rectangle. But we do get one more congruent side. And actually, another set of parallel sides out of that too. But hey, 4 congruent sides. That is at least a rhombus. We know that we cannot get more specific than rhombus because if you look at your Venn diagram, the only thing contained inside of rhombus is square. And we don't have the right angles we need for a square. So this is a rhombus. Last one. A is at -4, -1. B is at 1, 4. C is at 3, 0. And D is at 0, -3. So there's A, B, C, and D. And one thing I can tell, these sides look pretty parallel. We can double check. This one has a rise of 1, 2, 3, 4, 5. And a run of 1, 2, 3, 4, 5. So AB, the slope is 5 over 5, which reduces to 1. And then on CD, the rise is 1, 2, 3. The run is 1, 2, 3. And 3 over 3 also equals 1. So from that, we know that AB is parallel to CD. And we can kind of just tell by looking that BC and AD are not parallel. So since we have exactly one set of parallel sides, this is some kind of trapezoid. Looking at your reference sheet, we could get more specific if we know that it's an isosceles trapezoid. So what we have to check is if these two lengths are the same. So we need to check, is AD congruent to BC? Well, for AD, I have a rise of -1, -2. And a run of 1, 2, 3, 4. And I'm going to put that in my calculator real quick. I get 2 square root of 5. So if BC also has a length of 2 square root of 5, then it's an isosceles trapezoid and we're done. If it does not have a length of 2 square root of 5, it's just a trapezoid and we're done. So let's see, the rise here is -1, 2, 3, 4. And the run is 1, 2. Put that in my calculator. And again, 2 square root of 5. So these two sides are congruent. That means this is an isosceles trapezoid. And we are done. So I finished that up right when the live stream hit an hour. Like an hour and 20 seconds, but the first couple of minutes I wasn't actually doing anything. So if anyone has anything not creepy to put in the chat, happy to answer any questions that you've got. I'll stick around for a minute or two and then I'm going to end the stream.